For A, we're trying to find g of 1, g prime of 1, and g double prime of 1. So we're going to start with g of 1. We're going to use our definition that g of x is equal to the antiderivative from 2 to x of f of x dt. So one of the things that I want you to notice is that g of x is your position or your original function and f is your derivative. Because as we use the fundamental theorem of calculus, if we take the derivative of g, that's the same thing as taking the derivative of 2 over x. So these cancel, so g prime is equal to f of x because of the fundamental theorem of calculus. So now let's find g of 1 first. So we're going to substitute 1 wherever we see an x. So notice that my upper bound goes from high to low, so we're going to change that to go from 1 to 2, and we can do that by making it into a negative. So now we're trying to find the area under the curve of f, which is, this is the graph of f, from 1 to 2. So if we go from 1 to 2, it's a triangle, so it's going to be 1/2 base times height. My base is 1, my height is 2. And notice that it's a negative. The reason it's a negative is because it's below the x-axis, and I still had this negative that I needed to write here. So now we're going to find g prime of 1, and because of the fundamental theorem of calculus, we know that g prime of 1 is equal to g of 1. Okay, so that means that when f is 1, or when x is 1, y is negative 2. So now we're going to find g double prime. So g double prime would be the derivative of f. So since we're looking at the derivative of f, the derivative means the slopes of the curve, or slopes of the tangent line. So we're looking at x equals to 1, we're looking at the curve. So one of the things that you should notice is that from the left, my curve is negative. From the right, my curve is positive. So my derivative is not going to exist. So g double prime does not exist.